Hello everyone and welcome to my ISE of Discrete Mathematics. My name is Sadiq Aslam Hawaldar, roll number 2014. I have two topics. One is functionally complete sets of connectives and other is other connectives. We learn one by one. First one, that is functionally complete sets of connectives. What are these? Okay, any formula can be expressed in terms of equivalent formula containing the connectives from functionally complete sets of connectives. So we can express in any formula which contain not and not or. So these are called functionally connectives, complete sets of connectives. Now what are that? We learn by taking the example. The example is P and with bracket containing Q biconditional with R. The biconditional can be again expressed in terms of conditional, that is Q is conditional with R, again and which is with whole bracket R which conditional with Q. This again can be divided or you can say expressed containing not. So not of Q, P and whole bracket in that containing not of Q or with R, and which is and again with not of R or with Q. So this can be again we can further express by taking not outside the bracket. When we take not outside the bracket, that the Q taken not outside the bracket, the Q and not with R. Why this have not come to R? Because not become normal. Okay, so and with again this not containing the bracket R and not with Q. So we can say this, we can also express using De Morgan's law. De Morgan's law is used for converting and with or with and. So P and Q, which is by condition, which is equal to not of bracket containing not of P with not of Q. P or Q, which is again can be expressed in terms of not in bracket not of P and not of Q, because when not enters it will change from and to or to and. These are minimal sets. Okay, the arrow 2 which here is showing is our minimal sets. We can call this NAND or NOR. What are that we are going to study in the other connective. Now these are my second topic, that is other connective. Other connectives contain three parts, that is exclusive or NAND or not. What is exclusive or? Exclusive or symbols is like or bar, but I didn't get that symbol, so I use this logical symbols from electronics. We have taken the table PQ and P exclusive are with Q. So we have taken in that some truth values, that is true true false false, in Q true false true false. Now how the outcomes are come here? Here outcomes come when we get the similar TT or similar FF, it is false. When it is different it is true. That is for exclusive. Now we are going to study the next table, that is NAND. What about the NAND? NAND P, which is here arrow upward arrow, which is we call NAND, okay, which is equivalence to not of bracket P and Q. Now what have we taken? We have taken the truth values for P and Q, that is true true false false, and Q, that is true false true false. How the outcome comes here? We know what are the outcomes of and. When true, when both the values are true, then the outcome is true. Okay, similar here what this have taken the negation of that and, means if both the values are true then it is false, when one of the values are true then it is true. In that and case one of the values is true and other is false, then we get false. So this is the opposite to and, so it can be taken equivalence with not in bracket P and Q. Now next what we are going to study, that is NOR downward arrow, that is P downward arrow with Q, which is equivalent to not P or Q. Now we have taken here truth values, that is true true false false, Q true false true false. What are the we getting the outcomes? In similar we are getting the outcomes in the or, that one of the values is true, we get values true, but it is negation to or. So if one of the values is true it is false, When the both values are false, it is true. So this is NOR. When both the values are true, it is false. In what we get, when one of the values also is there true, okay, in OR we get true, but here not we getting, because this is negation to that of OR. Or we have studied the basic logic gate, basic logic, biological. So this is NOR gate. Thank you.